Hey everybody, I hope you're doing well. I look forward to seeing your faces again real soon. This video is intended to just help stir up the dust on some things that are going to help us to hit the ground running with our next unit, which is about sampling distributions and then inference that will follow. First of all, I want to apologize. It is cold in here, so I hope that doesn't distract you as we continue through this. But okay, most of what we're going to be doing in the second semester is inference procedures. All right, and there are all sorts of things some terms that we got to be able to refer to correctly. For instance, statistics versus parameters. We get statistics are is a number that describes a characteristic of a sample, whereas a parameter is a number that describes a population. Okay, and then these values are generated from samples or surveys, and then parameters are generated from a census, or whatever that is. Okay, it is oftentimes impossible or impractical to do a census, so we use statistics to allow us to estimate population parameters. That's kind of the whole deal of statistics. We use samples because it's easier than censuses, or possible. All right, some key things that we have also talked about too. We talked about means, and when we're talking about the parameter mean, the population mean, we would use mu, the Greek letter mu, or x bar for the sample statistics. So x bar samples will help us predict mu's population parameters. We're talking about proportions. Proportions are going to be fractions of things, percentages of things. We will use p is going to be the letter that we will use for population proportion, but then p hat, yes, I have it on, is what we'll use for the samples proportion. And then standard deviation, sigma is the population parameter, and then SS sub x or S would be the samples. Standard deviation, sometimes we'll call that the sample error. Okay. The whole point of statistics is that a sample must be representative of the population. Things that prevent it from being representative, of course, would be bias. So in that first unit that we did back at the beginning of the year, we talked about forms of bias. And the thing that helps to reduce bias in general, to help a survey, to help a sample to be representative of the population, is that it must happen randomly. I don't know if you recall, but there was a point in time when we had something that you thought you did randomly, but you didn't, but there was bias. Everybody had biased representations when you did not choose something randomly. And if you have the opportunity to be more representative via a cluster or a stratified or a systematic sample or what have you, that's great. But randomness is key to having a sample that's representative. Okay, the next thing that is critically important about a sample is that it involves independence. Now, here's the deal. Most of the time when a sample is taken without replacement, meaning if you take something out of the population, you don't put it back in before you take the next one, which means the denominator changes. So a very simple example here, if we're talking about drawing 2 aces from a deck of cards. There's 4 aces out of 52. The probability of drawing the first ace is 7.7%, but then the probability of drawing the next one is 5.9%. So they are not independent of one another, which is, I'm going to contradict something here in just a moment, but still, that is showing that these are not independent events, because taking the first ace absolutely changed the probability of the next one. However, if our population is bigger, let's say we're drawing from 10 decks of cards. So I got 520 cards, and there's 40 aces in there. Now the probability of the first one is 7.7%, but then the probability of drawing the second ace is much closer to that 7.7%. It didn't change nearly as much. And then if we increase our population even more to 20 decks of cards, you can see that the probability of the first one doesn't change, but probably the second one is much, much closer to the original. So therefore, there's something going on here with the population being bigger and the potential for independence. So when we don't have replacement. This is going to be the rule. We will be able to declare independence when the sample is less than 10% of the population size. Now, I contradicted myself earlier because 4 ACEs is less than 10% of 52. However, that population size is just not big enough for this to matter. We will be looking at proportional things like this. There's a couple of nuances with this. However, in general, if your sample size is less than 10% of the population, we will be able to declare a sample as independent. And then the third important thing, it's got to have representation, representative sample. It's got to be independence. And then in order to really be able to evaluate a sample, we need to know what type of distribution that it is, whether it's normal, whether it's binomial, whether it's uniform or whatever. And well, there's more to come on that. So, but those are some key introductory pieces.